Hey everybody, I'm going to do a quick video on how to do activity 4, sources, sinks, and feedbacks. So I'm going to go ahead, I'm on the High Adventure Science, and I'm going to go ahead and begin activity. So this has to do with kind of how the atmosphere and oceans interact as far as the amount of carbon dioxide in them. So it's called the carbon cycle. And it says the carbon dioxide is constantly being added to the atmosphere through both geological and biological processes. Can you think of some biological processes that add carbon to the atmosphere in the form of carbon dioxide? As rocks are weathered, carbon dioxide is released. Living organisms release carbon dioxide through respiration. That's what we call breathing, right? And when they die, they release carbon dioxide as they decompose. Extra carbon dioxide is released when materials are burned. These are all sources of carbon dioxide. With all of this carbon dioxide being added, why isn't the CO2 level in the atmosphere much higher? Like water and other substances on Earth, the carbon in carbon dioxide is recycled. This means that carbon is neither created nor destroyed, but moves between various reservoirs or storage spaces on Earth. The spaces that take in carbon dioxide are called sinks. The flow chart shows the movement of carbon dioxide between Earth's carbon reservoirs. For example, carbon dioxide in the atmosphere can come from the land and the ocean. It can also be stored in the land and the ocean. Follow the arrows in the chart to see how carbon dioxide moves between different reservoirs. So the reservoirs are the atmosphere, the ocean, sediments, and land. And you can see that sediments can move carbon dioxide to the land can move carbon dioxide into the atmosphere through weathering, the atmosphere can dissolve carbon dioxide in the ocean, and the ocean can deposit in sediments. And the ocean can also release carbon dioxide into the atmosphere, and the atmosphere can deposit into land through different processes. So lots of different ways for the carbon dioxide to cycle. Questions? Which statement is true about the carbon dioxide cycle? And is there a reservoir that serves only to take in carbon dioxide? So go ahead and answer those and click Next. Next, we're talking about carbon dioxide solubility in the ocean. What does that mean? It refers to how much carbon dioxide can dissolve in the ocean. It says the ocean has many substances dissolved in it, including salt. Have you ever been to the ocean and water got in your mouth? It's really salty. If you try to dissolve salt in a glass of water, you'll find that more salt dissolves in the water when the water is warmer. The solubility of salt in water, how easy it is to dissolve salt in water, is affected by temperature. The solubility of gases is also affected by temperature. How does the solubility of a gas change with temperature? The picture below shows the model you'll use to answer this question. It shows interactions between Earth, land, ocean, and atmosphere. Sorry. So this is a screenshot. You see there it's similar to models we've used in the past. You can go ahead and slow it down, hit play, and we can increase or decrease the temperature. And we can see over here, the red line shows temperature. So we dropped the temperature, it looks like down here, then raised it. You can see the corresponding blue line, which is the ocean temperature. It takes a little while for the ocean to warm up and cool off. It has what's called a latent heat, which means that it takes a lot of energy to warm and cool the molecules of water. Then here's a graph that shows the amount of carbon dioxide in the atmosphere and the amount of carbon dioxide in the ocean. So what you're going to do is take a look. When the ocean temperature went way down, what happened to the amount of greenhouse gases in the model? So the green one shows carbon dioxide in the atmosphere. What does it do when you drop the temperature of the ocean and then raise the temperature of the ocean? You can see how it went up there. And the one at the bottom, you can see that the amount of blue is carbon dioxide in the ocean. I'm sorry, the first one was in the atmosphere. This is in the ocean. In the ocean, there's carbon dioxide, and then all of a sudden it kind of goes away. It goes really low when the temperature goes up. So start taking a look at those relationships. Answer the questions. So I'm not saying this is a correct answer, but certainly it says use the picture of the model to make a prediction about the effect temperature will have on the ability of CO2 to dissolve in the ocean. Will higher temperatures increase or decrease CO2 solubility? Higher temperatures, all right, so that'd be the blue line going way up. CO2 solubility refers to the blue line down here. Go ahead and answer that and explain your prediction. I'm going to go on. Now you're going to use the model. It says use the temperature slider to increase and decrease the temperature of the ocean, actually be changing the temperature of the planet. It says the ocean temperature will change with the planet temperature. The temperature of the ocean is shown with a blue line. Notice the ocean temperature lags behind the planet temperature slider. Watch the graphs and see what happens. Kind of a hack here, a tip. Always go to the extremes with these things to kind of get the relationship. I think that really helps. What I mean by that is, I'm gonna go ahead and click this to slow. I'll hit play, and here's the temperature. We can just watch it for a little bit. You see the temperature here, ocean temperature is remaining stable, as is the air temperature. You can see the CO2 in the atmosphere and the CO2 in the ocean on the bottom graph. Now let's change it. Let's drop the temperature to 0. That's what I mean by extreme. Go ahead and push it to its limits. Hopefully then you can see a relationship occur. So as we cool the ocean, what is happening to the amount of carbon dioxide in the ocean? That's the blue line at the bottom. And what's happening to the carbon dioxide of the atmosphere? So the ocean gets colder, you can see, oh, the blue line at the very bottom. What's happening to it? It is increasing, right? It went up a little bit. And at the same time, the green line at the bottom went down. So where's the carbon dioxide moving? If it seems like these are kind of mirror images to each other between the ocean and atmosphere, right? So as the ocean releases carbon dioxide, the atmosphere gains carbon dioxide. As the atmosphere loses carbon dioxide, the ocean gains it. So the ocean is absorbing, is dissolving carbon dioxide and giving it off. Now let's go the other extreme. Increase temperature, crank it all the way up. It'll take a little while. I mean, we could speed it up, but why? Are we noticing any changes? Well, certainly the line at the top, the blue line showing the ocean temperature is increasing. We warmed up the planet. The ocean temperature is catching up. So as the ocean temperature increases, what about the blue line at the bottom? The amount of carbon dioxide decreases. So warm ocean water can't hold as much carbon dioxide. Do you see that? And where does that go? Into the atmosphere. Because now the level of carbon dioxide in the atmosphere is going up. Okay, I'm going to let that run. Which graph shows temperature in the ocean? Which color line represents the amount of CO2 in the atmosphere? How does the water temperature affect the amount of carbon dioxide that can dissolve in the ocean? Okay, so the higher temperature of the water, the blank. More, same, less. You fill it in. CO2 can dissolve. The lower, I'm just keep going here. The lower the temperature of the ocean water, the blank CO2 can dissolve. And which statement best describes the relationship between temperature and solubility of carbon dioxide? Solubility means the ability for it to dissolve. When the ocean temperature is higher, so when it's hot, less carbon dioxide can be dissolved in the ocean. More carbon dioxide can be dissolved, or there's no effect. Now, here's the argumentation box, right? That's what we're learning to do. So in the argumentation box, I'm not saying to pick my answer, okay? I want you to pick the answer you think is correct. It says, of course, in the real world, we can't just magically change the temperature of the Earth with a slider. Which choice best describes the relationship between atmospheric CO2 levels and its absorption by the ocean? When atmospheric CO2 levels become higher, okay, so when there's more carbon dioxide in the atmosphere, which of these do you think is true? Less carbon dioxide is absorbed by the ocean, the same amount is absorbed by the ocean, or more is absorbed by the ocean? And explain your answer. Now you see I just did a line. I didn't want to do an explanation just so you had a chance. But it does give me a clue at the bottom. It says you haven't explained your claim about the relationship between atmospheric carbon dioxide levels and carbon dioxide absorption by the ocean. So what relationship is there between the amount of carbon dioxide in the atmosphere and the amount that is absorbed by the ocean? It says run the model again and watch the CO2 graphs as you change the Earth's temperature. How does atmospheric CO2 affect Earth temperature, and how in turn does Earth temperature affect CO2? And remember, I think I mentioned what was going on there. Can we go back up? Atmospheric is the green, and ocean, and then temperature, right? What happens to when we heat up the planet? What happens to the amount of CO2? And then tell me how certain you are about your claim. What did you see? And I didn't just wrote the letter N. You haven't explained your certainty rating. What did you see in the climate modeling graphs of temperature and CO2 that influenced your certainty rating? What other information affected your certainty rating? Okay. I'm going to move on to the next. Now we're going to take a look at water vapor. It says in the previous models you saw that carbon dioxide traps infrared radiation in Earth's atmosphere and the temperature increases as you get more carbon dioxide in the atmosphere, right? Remember that graph that we've done since the beginning of this unit. The actual temperature increase on Earth is greater than what would be expected if only carbon dioxide levels were taken into account. So what's missing from the model? In the last model, you learned that oceans play a role as a reservoir for carbon dioxide, right? A sink. Carbon dioxide is dissolved in the ocean, and so it's not in the atmosphere. So it can't cause the Earth to warm if it's stuck in the ocean. But oceans play more than one role. In this model, you'll explore the relationship between temperature and water vapor levels. Experiment with the temperature slider below the model. Same thing. And we look over here. Red is air temperature, blue is ocean temperature, same before. And now we're going to look at water vapor in the atmosphere. So, just wonder if there's a way to turn off the others. Yeah, I can turn off. Oh, that's for that one. Never mind. I'll just let it run. I'll go slow. And then I'm going to let's decrease the temperature first. We're looking at the black line. Holy cow. The black line, when I decreased the temperature, the black line went straight down. Well, I'm gonna push it up a little at a time. What happens to the black line every time I push it up? So I'm increasing the temperature. What relationship can you see between the temperature of the planet and the amount of water vapor in the atmosphere? Well, every time I make it go higher, the amount of water vapor in the atmosphere goes up. Got it? Let's move on. What color line represents water vapor? How is infrared radiation represented in the model? You'll remember that from before, right? How does infrared radiation interact with a greenhouse gas? Remember we had that before as well. You're looking at the purple and you can see as it hits greenhouse gases, what happens to it. You can see how they bounce around. What's the relationship between water vapor and temperature? This is the point of that, what we did. So again, when you're stating a relationship, you're going to state one variable as, and one of the variables here is you're comparing water vapor and temperature. So you can say as the amount, how about the temperature? Yeah, you can do either one. As the amount of water vapor increases, the temperature does what? Notice I'm not saying that it causes it. There's just a relationship between them. Next is your argument page. Water vapor is a greenhouse gas. What do you think will happen to temperature when the amount of water vapor increases? Well, you would say that temperature will increase, decrease, or no effect. Hopefully you said that it'll increase. Explaining your answer. Remember, when you explain your answer, look at the graphs. How does the temperature change when the water vapor changes? Okay. How do greenhouse gases such as water vapor affect Earth's temperature? How certain are you? And then explain what influenced your certainty rating. So what did you see in the climate model and graphs of temperature and carbon dioxide that influenced your certainty rating? What other information affected your certainty? What things about this made you certain that, let's say you said that water vapor increases, the temperature will increase. I can resubmit and then next. Now we're going to combine the effects of carbon dioxide and water vapor. It says in previous models, you used a temperature slider to set the temperature. While this helped you to figure out the relationships between temperature, carbon dioxide uptake by the ocean, and the amount of water vapor in the atmosphere, it's not very realistic. This model shows all of these relationships interacting with each other. Just as in real life, the only factor that you can control, I don't think you can control the weather, you can control is the amount of carbon dioxide emissions. Use the human emissions slider to change the amount of carbon dioxide in the atmosphere. Watch the graphs to see how the temperature and level of water vapor change as carbon dioxide levels change. The human emissions slider controls how much carbon dioxide comes out of the factory. 0% means there's no human emissions. All right, we're not burning any fossil fuels and nothing. 100% means how many we put out in the year 2010. 200% means the human emissions that are twice the 2010 level. Okay, so there it is. Again, I always like to go slow here. Press play. There's the 2020 or 2010 levels. You can see what effect it has. Kind of let it play a little bit. What effect it has on the air temperature. Now this is temperature change, all right? It's not actually 0 degrees Celsius. This is the change. Remember, um, how much is going to change from that level. And you can see as we let it go, the 2010 levels, the temperature seems to be going up. Well, what do you think will happen when we decrease it? Put it down to 0. You can see there's a little bit of a lag. Nothing happens right away. It's not immediate, right? Still going up. And there it starts to turn around. I had a little dip there. Notice it's not going up, also it's not going up as steeply, and now it's kind of leveling off. It kind of tells you that even if we do change, if we completely stop, it's not going to have an immediate effect on our climate, is it? To me, it looks like it went up pretty steep and now it's kind of wavering, and oh, finally, years later, it starts to come back down. Okay. Then we can certainly crank it up to 200, and now we're putting out twice the amount of CO2 as we did in 2010. And you can continue to watch what happens. Answer the questions. What does the human emissions slider do? How does the level of carbon dioxide affect the level of water vapor in the atmosphere? Increased levels of carbon dioxide increase, decrease, or do not have an effect on carbon dioxide levels. You can look at the graph here. See if you think there's an effect, and then explain your answer. And then your last argument. What happens to the temperature when the atmospheric CO2 level increases? I just put temperature stays the same because you probably know that's not the right answer. And explain your answer. How certain are you? Remember, when you explain, refer to what you see in the model, okay? Make comparisons of what you saw with the CO2 and temperature. And then finally, explain what influenced your certainty rating, just like before. I'm just going to hit next. Your last part of today's lesson has to do with what are called feedback loops. And that's kind of how the climate is. So it's pretty complex, our climate. And what you saw here was an example of a positive feedback loop. When there was a change in the system, when we increased the amount of greenhouse gases, it increased the temperature. And an increase of the temperature caused the greenhouse gases to go up. So a positive feedback loop is something that a change causes something to cause it to go up, even an increase causes something else to occur to cause it to go up even more. Now, the example they give here is like studying and grades, right? Positive feedback would be the more you study, the better grades you get, right? And then the better grades you get, that's going to motivate you to study more and get better grades. I think another one would be like lifting weights, right? You go lift weights or do push-ups, the more you do, the more you can do. So the more push-ups you do, the stronger you get, causing you to be able to do more push-ups. All right, the more weight you lift, the more often you lift weights, you build that muscle, causing you to be able to lift more weight. That's a positive feedback, okay? What a negative feedback would be. A negative feedback would be if you do something that would actually cause it to go, something else to go down, and that would cause whatever you did to decrease. An example would be like clouds, right? If we think of more, if there are more clouds, that's going to cause more sunlight to reflect, which is going to cause the Earth to cool, which is going to cause us to have less clouds. So it counteracts. That's a negative feedback. Maybe not the best example. All right. Describe a positive feedback system that affects Earth's temperature. And then it says, obviously, since Earth has had ice ages in the past, temperatures don't only increase. What are some things that could decrease Earth's temperature? See if you can come up with some there. And then that is it. I know it's a long lesson, but hopefully you learned a little bit today, and our next lesson will be more about feedback loops and understanding them. I hope this helped.